So, hello everyone, and welcome back to the Rancher by SUSE booth here at KubeCon North America, Chicago.
My name's 2023.
It's 2023, right? We were actually wondering before we started which year it is, because this week has been a little bit of a whirlwind for us. So, yeah, but my name is Tim Irnich. I'm the product manager for Telco Edge here at SUSE, and with me is...
I'm Andrew Gracey, and I'm the product manager for Industrial IoT and Manufacturing at SUSE.
All right, and we are going about automating remote edge deployments. I had to actually check what the title of the presentation ended up to be. So, and that is about one specific aspect of our edge solution, which is like, how do we actually bootstrap infrastructure so that it can be used in the context of an edge scenario. And we have several ways of doing that, and we're going to take you through how that looks like. So, the premise of all this is that we're trying to build a solution that eliminates the need for skilled technical personnel on site. Because one key characteristic of the edge is that the devices can be anywhere. And that typically means that you don't have on the one hand side, the technical capabilities, but also not the staffing that you typically have in a data center scenario. So you need to make it, you need to set things up in a way that the typical technical skills profile that is available at an edge site, which can be a retail store or it could be a container ship, is able to actually execute the technical procedures that are required.
It could even be like a satellite where you don't even have anybody out there
like,
very difficult
no
to get
staffing whatsoever.
The space. Yes.
All right, so. And there are basically three ways or three different situations we see in the market for which we have built tailor-made solutions, or in some cases are in the process of building them. The first one is what we call directed network provisioning, which is pretty much let's say a mini data center that gets provisioned remotely kind of scenario. So we have typical data center grade hardware with out-of-band management controllers, like that could be your typical Dell server, your typical HPE server, and they are well connected. They have stable network connectivity. The endpoints for out-of-band management are known to the central management infrastructure, and we are building solutions. We're building Kubernetes native solutions with Cluster API and MetalCube because that's basically the ideal scenario for those technical components. So we have that, and we're going to take you through how exactly the process of setting up infrastructure for that scenario looks like in a second. But I want to be talking briefly to the other two scenarios. The second one is what we call phone home network provisioning. So there is still a network connection between a central management infrastructure and the actual physical machines on the edge side. But there are some particularities that we need to deal with in this scenario, and that is that the network connectivity is basically your typical DSL line. So it's a NAT router. It has one public IP address with like a hidden private network behind the router or behind the gateway, and that's where the machines are located. So you basically cannot phone into the edge side, but the edge side can call out to the management infrastructure. And for the initial bootstrap scenario, that basically means that the information the edge node needs to actually find the right management server that it's supposed to talk to needs to be somehow manually placed in the edge node. And we have a particular way of doing that Andrew is going to talk to later on. The third scenario is basically where we can either not assume connectivity to a central management server at all, or we just don't know enough about, or we either don't have the capabilities to enable the other two scenarios, or the customer prefers to be completely independent. And Andrew is going to talk to the third scenario we have, which is image space provisioning.
Yeah, and then sometimes in the edge, you just don't have any guarantee of network at all. It might be fully air-gapped. It might be effectively air-gapped, where you are actually... maybe you're on, say, like a spotty 4G connection, or you are on a satellite connection where you have so limited bandwidth, or you've got flaky enough bandwidth or enough jitter where anything that you do that actually requires networking, the network isn't there for you anyway. So you need to be able to set everything up on site and then be able to do the updates out of band. While on site, as an optional kind of update path there. So yeah, with that, let's go ahead and go through the directed networking role.
All right, so let's take a look at in detail in how directed network provisioning works. So it's basically the starting point for the process is that you have an unprovisioned server that gets installed in an edge site. It doesn't have an operating system on it. It is basically like it could have a completely empty disk, and the only thing you need basically is to make the location or the way to talk to the out-of-band management controller known to the central management server. Like you basically need the URL or the IP address of the BMC, and you need credentials for the BMC, like a username, password, or a certificate, so that you can authenticate against the machine. And then you need to basically put that information into the management server, and that is equivalent to enrolling the machine in the machine inventory that the management server has. What then happens is that the machine will basically be inspected in the sense of identifying what exactly is the hardware that is in this machine. Like, what is the processor model? How much disk does the machine have? How much memory does the machine have? And a lot of other details, like what BIOS version is installed. So I think there are probably like 40 or 50 different pieces of information that are collected during the inspection process. As soon as the inspection process is complete, the management cluster has enough information to basically decide how this machine should be used. And then it's actually up to the operator to instruct the management server to use that machine to create a cluster. So it can either be a single node cluster, it can be a multi-node cluster. So what happens as the next step is to basically create a logical object that represents a Kubernetes cluster on the management server, and also the corresponding machine templates, which define like the operating system level configuration of the machine, have to be provided to the management server, and that then enables the management server to initiate the actual mapping of available machines in the inventory to the cluster, so it can kind of pick the matching machines according to the machine templates and the cluster definition from the inventory, and then it starts the operating system level and the Kubernetes level installation, and then the management agents that are needed to for Rancher to actually do its usual thing are installed on the cluster, and then from there it's basically business as usual for Rancher. It has a couple of machines that represent a Kubernetes cluster, and then workload rollout can happen, lifecycle management can happen, and everything. So that's basically the directed network provisioning in a nutshell, which is, as I said before, the scenario we use when we have the right types of hardware and when the operational procedures the customer wants to use are in line with this particular scenario. So let's move on to the phone home network provisioning, Andrew.
Yeah, so for the phone home network provisioning, this is, and that is surprisingly hard to say, this is basically all the same steps, but a little bit out of order because we know different information, and we have different capabilities to touch that machine in this scenario than we do with the direct network provisioning. So we start out, and actually let me go through the other piece first. This is really for scenarios without the BMC or inbound access, but typically you obviously still need some level of network access back up to Rancher to be able to do this. We are basing this off of the FIDO device onboarding flow. We are working on a customizable out-of-box experience where you can actually take something, well, obviously out of the box, and then have a better experience for that technician who's on site or the non-technician who's on site to be able to do that initial setup. And then we are also going to be rolling in CAPI in future releases, and that way we actually get a lot of the same process and the same flow as we do with the directed network. So with this flow, we start by building a rendezvous address into the onboarding image. Then we build it. Well, then we bootstrap the node with that onboarding image. Then we shift that node to site. When it comes up, it will And honestly, all you have to do on site is cable it and then turn on the power. When it turns on, it will call back home to your Rancher instance that registers, and when it does that, you can get some level of first boot scripts to run to do some additional configuration that's specific to that site. Then you add the machine to your cluster, same as what Tim was talking about. It's a fully declarative mechanism, so you can define your cluster. That turns around, triggers all the scripts to install your Kubernetes onto the nodes. It can also turn around and also update your operating system as well. And then last, it will go and deploy the workload using a GitOps or manual process. One thing to note is that several of these can be rearranged flow-wise when needed. So you could set all of your definitions up ahead of time, or you could wait until after everything's actually shipped out to do that. Just depending on what you know and when. So let's go ahead and grab the next slide.
Just to recap, the key difference between this scenario and the first one is that in this case, it's sort of out of the edge side towards the central management infrastructure.
Correct.
And in the previous one, it was like the central management infrastructure contacts the edge side and initiates the process that way.
Correct.
Right?
It's a pull versus push, and so it depends on honestly the security of your network, what you need, what access you have, and what hardware you have to actually support that push.
Right. All right. Let's take a look at the image-based provisioning.
Yeah, so the image-based provisioning is the one that we are currently building out now and are expecting to release, I believe, in the spring. Hopefully I'm correct on that and not lying. But this is one where we want to support air-gapped environments, right? We have a lot of our customers who just can't trust the network enough to even go with one of the other two. The other two processes.
The other two don't work without connectivity to the management server, right?
Yeah, you have to have some level of base connectivity.
If it's network initiated or central initiated, the management server has to be there, and without it doesn't work, right?
Yeah, this is where you really have no connection between, or you have a connection that you just cannot or do not want to trust. Yeah, so in those environments, we're building out an image that will give you all of the capabilities that you have to define what the workload is, and even all the way down from the workload to the OS, and maybe in the future even the firmware, right? So we are giving a very declarative way to define the entire stack ahead of time. The setup of this can actually be automated through a CI/CD process. We're being very intentional so that this is very easy to use and something that is replicatable and you can get reproducible builds with.
And it's also possible to pivot into the other scenarios from here, right? Like you can actually sort of import the clusters that you're creating from the installation image into Rancher, so you kind of end up in the same place that you end up in for the other scenarios.
And that's very important for these low connectivity scenarios where you really don't want to trust it enough to actually set up. But day two operations, they can you can basically get eventual consistency, or if you are happy with eventual consistency of your day two operations, combining these methodologies gets you a very nice and usable system with, honestly, a best of both worlds, right? Where you're making the right risk-reward trade-offs for your scenario. So all the configuration is done in a simplified domain-specific language. Obviously, we're doing it this YAML because we are Kubernetes here.
Better or worse.
Yeah, it is what people know, right? So we're targeting a language that everybody can work in, everybody's familiar with, and everybody's comfortable with. So in this, we are supporting the configuration of networking, device drivers, and I've got to cheat and use my sheet, disk management, the operating system configuration itself, and any workloads on top of that. There will be more in the future as we come out with more and as customers request more from us. But that's those are the ones that we are building into the first release.
So what does it say SUSE workloads here? Can you talk to that for a moment?
I mean, the SUSE workloads would be the one that we directly support. And so
obviously
the
workloads has to be known to the image building tool because I mean either it has to be in a Helm repository the image build tool has access to or knows about.
Correct.
Right?
And we would be able to support third-party workloads as well, but obviously those are
I mean everybody can put stuff
party,
into
right?
OBS or into Package Hub and into our registries,
Correct.
right? Our partner team can help with that.
For sure. Yeah, so with this flow, you create the configuration, right? And then you would likely store that in a Git repo. You run our tool that builds the installer image. That will output, say, an ISO, but I believe we're also targeting QCount, AMI, those type of images as well. Then you take that, you boot that installer image either Pixie or through physical media or however you need to actually do to boot this image. That obviously installs it onto disk, and then it powers off. You ship this node onto site. When it's booted on site, the first boot will run some setup, and then the Kubernetes and then the workload all comes up alongside each other. It's a very clean flow, and it again gives us the best of both worlds between fully air-gapped and needing to also have future connectivity to upstream. Yeah, and with that, those are the three that we have.
Yeah, right. I mean, like, if anyone has an idea about a scenario that we haven't covered here, please let us know. Right? We want to hear from you. If this is not what you're looking for, if you need us to do something else, we're more than happy to take that into consideration.
Yeah, feedback welcome.
Yeah, right. And otherwise, I mean, we're pretty confident that the majority of what the customers that we've been talking to so far are covered by these three options. So yeah, we'll be back with more info on how this works in the marketplace once we've built everything, right?
Yeah. Yes, for sure.
All right, guys. That was it for now. Thanks for listening.